Chapter 9, Section 9.1, Inferences from two samples. In Chapter 8, we discuss proportion of one population's mean of one population and a standard deviation of one population. Here, we discuss proportion, mean, and a standard deviation for two populations. Let's assume that there are two different populations and we're discussing about the age. One population, there are three people with age of 25, 30, 50, and the other population has 5 people with age from 20 to 52. When I calculate the mean for the first one by summing all this and divide by 3 is 35. And also when I calculate the mean for the other populations, that one also is 35. So here, then we claim that mean of the first population is equal to mean of the second population. And sometimes, since we always discuss about the null hypothesis is equal or not equal or greater or less, what we can do when mean 1 is equal to mean 2, if I subtract mean 2 or if I move this to the other side, then would be mean 1 minus mean 2 equal to 0. So what's the opposite of that? Mean 1 minus mean 2 is not equal to 0, or mean 1 is not equal to mean 2. Second example is, let's say, at the first populations, the mean is 39. The second population, mean is 30. So mean of the first population is greater than mean of the second populations. Or if I subtract, the difference of these two is greater than 0. So this is the way we claim in this case. Or, and the third one, the mean on the first one is 29, means on the second one is greater, is 30. So that means mean number 1 is less than mean minus 2, or the difference is less than 0. So since we always, again, we discuss about equal 0, not equal 0, greater than 0, and not less than 0, here would be the difference. We discuss the difference. Again, if you have P1 minus P2, less than 0 is the left tails, greater than 0 is the right tail, and whether the difference is equal or not equal is 2 tails. So based on H1, we decide whether we have left tail, right tail, or 2 tails. We always decide based on H1. Same thing we did in Chapter 8. Now, there are all these formula that since you're dealing with two populations, then you have, and for first population, we had P1 equal x1 over n1. Here is P2 also x2 over n2. And in the formula for the z, there are also P with the bar at the top. The bar at the top is from this formula. And we discuss this when you go to the examples. So these are the formula that we use in these chapters. Also for the confidence interval is this large formula. To calculate the confidence interval for the difference of proportions of two populations, this is a formula. Margin of error is from this. In this example 1 is the left tail test with a significant level is 0.05. And now for this one, these are the formula that normally we use. Claim is these two licenses are equal. So here, proportion of the car with real license plates only. Are they proportion the same in Connecticut and New York? So we have information on each. For Connecticut, we have P hat. There are 239 out of 2049 car with a car license plate only. And the second population is 9 out of 550. So here we have P1 hat and P2 hat. So we do the calculation for these two. And what 5% significant level claim is that these two states have the same proportion of the cars. So first, one of the requirements that we have to do before we actually work on the problems, all these three. Two samples are simple random samples, which normally that's the case. Two samples are independent because car in samples are not matched or paired from two different states. So these two samples are coming from two different independent places. The most important one is this: n multiplied by p and n multiplied by q has to be greater than 5. Okay, so what is the claim? Claim was that these two are equal. Proportion of with the real license plate are equal. So the difference equal to 0. So original claim happened to be HO because HO always take equality sign. HO is they're equal, H1 is they're not equal. Remember in that the determination of tails depend on this sign. The sign, if it's equal or not equal, is always two tails. It's always two tails. And the area of two tails is 5%. So area of two tails is 5%. In that case, area in each tail is, when you divide that by 2, is 0.05. All right, so first, we want to find Z of a statistic. Z of a statistic in the formula is P1 hat minus P2 hat. It doesn't have the second part, is always 0. All right, and then P bar, Q bar. What is P bar? P bar is from this formula. It's mean of the first one plus mean of the second one plus N1 and N2. So we already have X1 and X2 is 9. And the second one is 239. So divide by the total N. And then Q hat is always 1 minus P hat. So here, this is X and N. So when we calculate P hat and Q hat, you substitute those in this formula. And proportion of P hat and E hat is always P1 hat is X over N. And P2 hat also is X over N, which is X2 or X1. And those are the ones that we calculate here. So Z of a statistic is 7.11. I'll show you later on how to use a calculator to come up with this number rather than going through all this long formula. So it's 0.05. Then if area of each tail is 0.025, what is the value of the Z? Inverse norm, remember inverse norm 0.025, it gives you the value, which is what? Minus 1.96, and this one is positive 1.96. So where does 7.11 fall? It falls into the critical area. This number, 7.11, fall into the critical area because the border point is 1.96. So we reject HO. When we reject HO, means here the claim is rejected. So we are saying they are not equal. And also the p-value when you use the calculator is almost 0, which is less than 5%. So remember, these two should always match. Now, for the same problem, we also want to find the confidence interval. The confidence interval is from this formula. P1 hat, we calculate that. P2 hat for each state. And then the difference. Margin of error is 1.96 Z of alpha hat. We already calculate that. P1, Q1 hat, we already have all these numbers. That gives us the margin of error. You put that in this formula. ish, give you the difference of these two proportions, which again, I'll show you later how to use the calculator. So the difference is between these two numbers. Where does 0 fall? 0 is not within this category or within this range. So in that case, the confidence interval limits do not contain 0, suggesting that there is a significant difference between the two proportions, or P1 minus P2 is not equal to 0. So Connecticut and New York do not have the same proportion of cars with the real license plate only. So how do we use the calculator to do all these calculations? This is the formula. If you want to calculate Z of a statistic, a stat test, two proportion Z test, that give you the Z value, and you want to calculate the confidence interval, you go to proportion Z interval. You input all these numbers, and when you come to confidence level, remember, you are using table A1. Table A1, it tells you that if you have two tails and significant level is 0.05, then it's 95%. So when you put that, that gives you the interval that we already calculated here. In these problems, when we go through all this calculation and we have this estimate, these two, using the calculator would give you that. Or here, to find the Z of a statistic of Z 7.11 or 7.10 is from this formula. These are again some examples. Very similar to that. Same thing, claim. And how to calculate using the difference of populations. This is the second examples. Here the claim is that truck P1 proportion of the truck is greater than passengers. P1 is greater than P2. So the difference is greater than 0. Based on this greater than 0, you understand it's the right tails. What is opposite of that? HO is always equal sign. So when we do the calculation, the Z value is minus 1.93, fall into the good area. So we accept HO. We do not reject HO. When we accept HO, means we accept this and we reject the claim. And also when you use your calculator, you find the P value, 0.97 is greater than significance level. So again, these two should always match. Means when you compare Z of a statistic with Z of the graph, and you come up with a conclusion of accept HO, P value also should indicate that HO is acceptable. Now, for all the homework problems, the first one is just the multiple choice. I did calculation for one of the problems, and I show you how to use the calculator for this, okay? So these values are all given. Claim is that it's P1 is less than P2. And here, front license plate at the higher rate than owner of the passenger cars. So this one has a higher rate than that. That means the passenger car, which is P1, is less than that. So that's the original claim. And the opposite is equal. So these are step by step of using the calculator and have the p-value and also the z of the calculations. And this is how to do the calculation to find the interval. You input all these numbers. And when it comes to confidence level, calculator asks you for confidence level, make sure you understand table 8.1. So I actually used that calculator for all these problems. Same thing here. Men and women, N1 and X1 are given, N2 and X2 are given. So you input all these informations. And H1 is not equal. Remember, H1 would determine two tails. In this case, it doesn't matter whether it's equal or not equal, it's always two tails. So P1 is not equal to P2. So the p-value is 1 and z is almost 0. And they ask for the interval. So they all apply the same formula. See, they all are applying the same format. And this one, the solution is at the bottom. So that would be end of section 9.1.